So this example, right, is an example of a trapezium prism. Okay, and this example is taken from a Set 2 exam or something. So in this case, right, you will cross out this one. Okay, take it as this is 10 centimeter. So if you need to calculate this, right, you actually need to know something that you learned in Set 2. So anyway, there's a missing coordinates here. Okay, so you look at the description. This is a solid block of iron, and they describe two vertical ends. So where are the vertical ends? Okay, A, B, C, D. So if you look carefully, A, B, C, D is like a trapezium. So this is a trapezium face prism. Okay, and all the other four faces are rectangle. So where are the other rectangle if you look at the description? So actually this part is a rectangle. So it is a slanted piece of rectangle. And then the bottom is also a rectangle. And then this part is also a rectangle. And then the top is also a rectangle. So these are the four rectangles that they are talking about. So in case you're wondering, where are the four rectangles? So this one is a 3D diagram. So it makes things a bit harder. So if you're going to get the surface area, you actually need the two vertical piece and the four rectangle as stated there. Okay, so anyway, okay, make sure you cross out CD. So we'll just take CD as 10 centimeter. So it's actually calculated by something called Pythagoras theorem. Okay, so let's get on with the second part. The area of this. So that is a trapezium. So we apply the formula of a trapezium. So you can choose to write out the formula so that you can be guided. So the height. So this will be the two parallel sides. So the height will be 6. So very much like your area and perimeter. You write out the formula, you put in the numbers, and then you punch calculator. So remember to give units. And then we'll like the volume of the block. So getting this volume is quite easy. So the volume is just whatever the cross section, multiplied by the length. So you are slicing the trapezium. So every time you slice, okay, a piece of trapezium comes up. So in part 3, that will be the volume. So it will be 84 centimeter square multiplied by 20 centimeter. So it's like your cross section. So I think this one is quite easy. Okay, you can try finding the surface area, the total surface area. Okay, so in this question, they are not asked for the surface area, but we can give it a try. So I'm going to try using the formula. So you can try using the formula, or you can try with the 4 rectangle pieces. Okay, so if I'm going to be using the formula, I will need the perimeter of the cross section. So if let's say, okay, let's extend the question. I need the total surface area of the iron block. So if I need that, I will actually need the perimeter. So the perimeter of the cross section will be 6 plus 10 plus 10. So don't forget this part is a 10. Get 44 centimeter. So how are we going to get the surface area? Okay, so let's follow the formula. So the formula says that there should be 2 pieces of the cross section, which is 2 pieces of the 84. So 2 pieces of the 84. And I'm going to make use of the perimeter to multiply by the length. So this will be the front and back. This part will be the front and back. And this part is actually the 4 rectangle. So if you add them up, that will be the total surface area. So the question never asked for it. I'm just showing it to you. And let's say, would you want to explore? Okay, if we want to explore, let's try to explore. What if you didn't use a formula? What if you decide to do piece by piece? Okay, so let's try. So we'll try to see whether the piece by piece will end up also getting 880. Okay, so we try to get this piece first. This piece will be a 10 times 20. Okay, then I'm going to try to get this piece. So that is also a 10 times 20. And I'm going to try to get the piece that's at the back. So that will be a 6 times 20. And now I'm going to get the one at the bottom, which is 18 times 20. So if you look at these 4 pieces, right, you go and add them up. I think it should have given you the same 880. So I don't know whether you realize or not. Where does this part come from? Actually, there is a common factor. So there is a common factor. There is a common factor. And it just happened that when you do it, take out the common factor, right? This is the parameter. So if you have done piece by piece, you will get the same area. But piece by piece means you gotta be super careful. So if I use a formula direct, I use the perimeter formula multiplied by the length, it straight away give me the 4 rectangle. And it cut short the timing a lot. So that's why I will encourage that you use the perimeter times length part rather than you go and add up piece by piece. It's very confusing if you're going to add up piece by piece. Okay, so that is for example 2. Okay, the next example is even more confusing because the next example is a pentagon prism. It has the face of a pentagon, but then right, there is a hole drilled in the center. So look carefully this part. They drilled a circular hole. So you gotta imagine how it looks like. So if I go for the cross section, right? So this is the slice that I'll be slicing off. So this is the cross section. So I'm going to explore the area of the cross-section. I'm going to explore the perimeter of the cross-section. So this is the tricky part. You got to listen up, or else you'll find it very confusing. Okay, so I'm going to find the area first. So the area will be the making up of a pentagon. But how am I going to get the pentagon in this situation? Okay, in this situation, right, my pentagon is made up of a triangle and a trapezium. Okay, so if you can see, there is a so in this case, right, it's made up of a triangle and a trapezium. You got to be very clear what you're doing. So please write it down. So for the triangle, it's half done based on height. So it's half times 9.75 times the height. For the trapezium, it is half times height, and then the sum of parallel length. Then you got to add them up carefully. Okay, so I hope I never press wrongly. Let me double check. Yep, correct. Okay, don't forget a hole was drilled. So actually I got to find out about the hole. So I got to subtract the hole. Okay, so area of the circle, pi r squared. So in this case, right, it will be 3/2 squared. Yeah, I'm not going to punch out the pi. I'm not going to punch out the pi because that's not my final answer. So now I'm going to explore the cross section. So the cross section will be the pentagon, and you subtract away the circle. So how are you going to get this portion here? So the area of the cross section. Okay, simply take the pentagon, and you minus the circle. Okay, then you bunch calculator. So that is the cross section. So that means that every time you slice, right, this kind of thing will come out. Okay, so then you got to multiply by the length. So this one is the cross section. Then you multiply by the length. So that's how I get my volume. So that is the volume. So the tricky one is to get the total surface area. So the total surface area, right, is not just the 5 rectangle. I don't know whether you can see that it's actually a rectangle. So this is a rectangle. And then here, there's another piece of rectangle. So there's actually 5 pieces of the rectangle, and not forgetting this part. The inner part is actually hollow. So this part, right, the part that's inside is also the surface area. Because you go and dig out a hole, you actually expose more area of the prism. So are you going to still use the same formula? Yes, I'm going to use the same formula. So if I need the total surface, if I need the total surface area, okay, there is some amount of, I forgot. For this question, again, there are some bidiagrams. Okay, so you actually need to find, okay, you will not be able to find, so let me just calculate for you. You need to find the parameter. You need to find the 5-sided regular parameter. Okay, again, there are some amount of bidiagrams that you can't do. So this part is 10.35. So I'm going to find the parameter of the cross section. Take a look. The parameter of the cross section will be the 5 sides. Okay, don't care how I get my 10.35. You will not know at this stage. This is a Sec 2 question also. The thing is, I need to add the circumference. I need to add the circumference. So a lot of people will end up subtracting the circumference. That's not correct. So perimeter is the sum of the edges. So you should be adding up all the edges. So including this circular thing is part of the edges. So a lot of people, oh, sorry, it shouldn't be, sorry, it's not 10.35. It should be 6. So if this is a 6 and it's a regular pentagon, so all this will be 6. Okay, my mistake. Okay. So it should be 5 times 6 centimeter. Then you add the circumference, 2 pi r. So that is the perimeter. So the common mistake is people will subtract the circumference. So we don't subtract because for perimeter we're adding up all the edges. So from here we calculate the total surface area. So I got 2 pieces of the cross section, which is this. But of course I'm going to use more decimal places. And I'm going to use the perimeter multiplied by the length. So let's try. So I get 502.4356. So 3 SF. So that's the total surface area. So when you got a hole being drilled, the edges is included inside the perimeter. You do not subtract. So that's one of the common mistakes.